The intermediate value theorem is one of our main theorems in calculus, and so I'll lay that out for you here and then we'll look at a couple of examples. So it says, first of all, we have to suppose that f is a continuous function on the closed interval from a to b. So this is going to be important. We're going to need to state this whenever we prove something using the intermediate value theorem. It falls apart if f is not a continuous function over that interval, so we need to make sure that happens. Okay, and let n be a number between f of a and f of b. So what that's saying is n is some y value between the y value at a and the y value at b. And note that f of a is not the same as f of b. So the y values at a and at b, those two y values have to be different. Okay, so those y values are different. N is some y value in between those y values. And if that happens, so that's just our setup. So f is continuous. We have two different y values at those x values of a and b, and then there's an n in between those. It says then there exists a number c, which is down here. It's an x value in the open interval from a to b. So it is between a and b. It cannot be at a or b. It's an open interval. But there is a number, an x value in between a and b, such that f of c is equal to n, which means that the y value at c is going to equal n. Okay, so again, I know this is a continuous function, and I know that my y values at a and b are different, and so there is going to be an x value between a and b where I hit a y value between the y value at a and b. Okay, that's the main setup. So one of the main ways that you use the intermediate value theorem is to prove that there's a root of an equation in between two x values. So show that there's a root of the equation 4x cubed minus 6x squared plus 3x minus 2 equals 0 between 1 and 2. So these are x values. So I want to show that somewhere in between 1 and 2, this function will cross through the x-axis essentially. So I'm going to call this function f. I know that it's set equal to 0, but I'm going to say that this function is f of x. And the first thing I need to state is that this function is continuous over this interval specifically. Okay, so you have to state some kind of reason why that's the case. In this case, it's pretty easy because our function is a polynomial. So I'm going to say because f is a polynomial, it is continuous. It is continuous everywhere because polynomials, the domain is all real numbers. And then I'm going to say specifically on the closed interval. So continuous on the closed interval from 1 to 2. Okay, because that's the interval that we're actually concerned about. So because f is a polynomial, it is continuous everywhere, specifically on the closed interval from 1 to 2. Also, okay, so now we're going to do a little bit of work to the side, then we're going to come back to this. So my work on the side is that I have to figure out what the y value is at the endpoints of my interval. So I need to figure out what f of 1 is and what f of 2 is. Okay, so f of 1, if I were to plug in 1 into this equation, we would have 4 minus 6 plus 3 minus 2. So that would be negative 2, positive 1, negative 1, if we plug in 1 into that equation. Okay, and then we also need to figure out what f of 2 is. So if we plug in 2, this term, if we plug in 2, would be 32 minus, if we plug in 2 here, we would have 24, plus, if we plug in 2 there, 6, and then minus 2. So that's going to, we've got 38 positive minus 26, so that's going to give us 12. Okay, so f of 2 is 12. Now keep in mind what we're trying to show. We're trying to show that there's a root in between those, and a root is whenever we have a y value of 0. It's whenever it crosses through the x-axis. So our setup here is that the y value at 1 is a negative number. The y value at 2 is a positive number. So if this function is continuous, that means we have to go through 0 to get from a negative number to a positive number. So we just need to state that. So here's how I'm going to do that. So because f is a polynomial, it's continuous everywhere, specifically on the closed interval from 1 to 2. And then I'm going to say also, since f of 1 is less than 0, which is less than f of 2. Right? F of 1 was negative, f of 2 is positive, and so f of 1 is less than 0, which is less than f of 2. So also, since that, then there exists a number c in the open interval from 1 to 2 such that f of c is equal to 0. Right? So, again, what we're saying here is we've got a continuous function between 1 and 2. The y value at 1 was negative. The y value at 2 is positive. So somewhere in between 1 and 2, we hit a y value of 0. It has to cross through 0. And that is the way that you're going to state that. Okay, so a lot of times the intermediate value theorem is used to prove there's a root. I'm going to show you an example where we're not going to prove that, but it's the same setup. So show that the function f of x equals x squared takes on a value of 7 in the interval from 2 to 3. Okay, so again, f is a polynomial. So it is continuous. Again, I can say everywhere, but I'm going to say continuous on the closed interval from 2 to 3. I know that because it's a polynomial. It's continuous everywhere. Okay, and then I'm going to say also, since, now I got to do my setup here and figure out what f of 2 is and what f of 3 is, but this should be pretty easy to do. F of 2, if I plug in 2, 2 squared is 4, f of 3 is 9. So 7 is between 4 and 9. So also, since f of 2 is less than 7, which is less than f of 3, there exists, and I didn't put this last time, I'll put this time, there exists by the IVT a number c in the open interval from 2 to 3 such that f of c is equal to 7. Sometimes you may be asked to find what that value c is. Okay, so c is just some x value between 2 and 3, where if I plug it into this function, I get 7. And so in this case, c is equal to the square root of 7. Right? Because if I plug in the square root of 7, square root of 7 squared would give me 7. The square root of 7 is in between 2 and 3. So that is what we're showing here. We're just saying that there is a number in between 2 and 3. You may sometimes be asked to state what that number is.